So at this point, we have covered in class a lot of the basics regarding ionic bonding. So you know what to do when given a piece of, a compound, maybe a cation or an anion, and you know how to find the charge. We've learned the crisscross. We've learned what to do if we have transition metals. The last piece of the puzzle, and this is a fun one, it's a big fat word, polyatomic ions. It's the last piece. And this is basically one last little layer. And first of all, before we talk about how to use it, let's talk a little bit about what it is. Polyatomic ions, let's do a little Latin root word analysis. Poly, if you think like in math class, like polygon. Poly comes from the word meaning many. So this poly gives us many, and atomic gives us atoms. So we're talking about an ion, right? Let's review. An ion has a charge. So we're looking at an ion, something with a charge, made up of many atoms. Up until this point, the ions that we've been looking at have been one atom, Na+, F-, S2-. All these are called simple ions. And they're called simple ions simply because there's only one atom involved. One Na, one F, one S. Polyatomic ions, though, are a little bit more complex. Instead of just being made up of one ion or one atom, they're made up of multiple ones. And if you take a look down here, this big chart here is the common polyatomic ions that we are going to work with a lot. Now, one thing that you'll notice is that there are lots of complicated formulas and lots of complicated names. The good news is you never have to memorize any of this. You'll always be given this chart, and you'll always be able to use this as a resource. So let's take a look at this chart down here. So these are all ions made up of multiple types of atoms. This number up here at the top is the charge of the ion. Over here, we'll start with the +1. There's really just one. And remember, if it has a plus charge, that makes it a cation. All the rest of these are all anions. So how to read this is you'll look, let's just do ammonium here as our example. You'll see the word name given in parentheses afterwards, ammonium, hydroxide, carbonate. That's the word name, and that's already taken care of for you. Remember how we used to have to change the ending to IDE? The nice thing with polyatomic ions is the ending stays the same when you're giving these things a name. The table has already taken care of the name for you, so you don't have to worry about that. Each one is made up, I'm going to switch colors here, each one is made up of several different atoms. Ammonium is made up of nitrogen and hydrogen, one nitrogen atom and 4 hydrogen atoms. The other piece of information that you're given here, switching colors again, is a charge. You're told that ammonium has a +1 charge. Now, some of these are a little tricky to read, and I kind of want to walk you through them a little bit. Nitrate, for example, has 1 nitrogen, 3 oxygens, and then it's hard to see. See that there's a little minus right there? That minus is the charge. It's a -1. See how this is in the -1 column? Don't be confused. Don't think that's a -3. That is not the case. That negative, it's a -1 because it's in the -1 column. That 3 tells you there are 3 oxygens involved. Now, how we use polyatomic ions is almost identical to using them how we've worked when we had simple ions like we did up here. The really easy part comes from the naming. So we're actually going to do that first. Go ahead, bop down here for me. We have 3 problems where you are given the chemical formula and asked to determine the name. So the first thing I'm going to have you do is go and get a periodic table. If you haven't yet, it's good practice. Go do it. Get a periodic table. And you can even pause it and come on back. So the first thing, when it comes to naming, the naming part is the simplest when it comes to working with polyatomic ions. So let's take a look here at this first one, KOH. The first thing that we need to do is identify the polyatomic ion. So take a look back up here at the polyatomic ion chart. Do you see any piece of KOH floating around up here? Hopefully you said, yes, Miss PB, I do. I see a hydroxide. Hydroxide has an OH. Now, some of you might be going, well, I saw this, but this has a little negative written into it right there. Let me erase that. Has a little negative written into it. And the answer is, it has it written up here, but remember that when we write the final formula for something, we don't write the charges, because those kind of get taken care of when we do our crisscross. So there's no charge, we don't write OH minus down here, but that's correct. So we say the OH and the OH is up here. So this is a hydroxide. Find K on your periodic table. I'll give you a little hint. It is an alkali metal. Did you find it? All right, so K is potassium. And then remember how I said here that the ending stays the same, that the table does the work for you in the naming? That's the case. We see potassium, the OH is hydroxide, so the name of KOH is potassium hydroxide. The name is done for us. Awesome, beautiful. Let's look at this next one down here. B2 parentheses SO4 parentheses 3. Okay, so let's take a look. So B, find B on your periodic table. Should be boron. And then find SO4 up here. That's a polyatomic ion. So let's look on our polyatomic ion chart. Do you see SO4 anywhere? Now remember, it's going to have a charge in the chart, but not a charge in the formula that we write. Boom. There we go. Sulfate, SO4 with a -2. Again, remember, the -2 is here, but we don't write it in the final formula. So that's boron sulfate. Easy peasy lemon squeezy. We got one more. We have aluminum. Again, so that's Al on our periodic table. And then if you look the other part, CrO4. If you find that, look up on the chart. And there it is, right there. It's a chromate. And again, remember, the table does the work in changing the endings for you. So all you get to do is just look at the chart, find the piece, and then write it down. So the slightly more complex variation of this is when you're asked to do the opposite. When I give you the word name and ask you to give me the chemical formula. And if you can see, that's like what these first three are up here. I give you the word name and have you do the formula. So I'm going to erase some of the stuff that I've drawn in here to give us a little more room. So let's take a look at what that might look like. So barium and carbonate. Your first job is to find these, or find the cation on the periodic table. If you can find barium, check it out. It's an alkali earth metal. Its symbol is Ba. And based on its position on the periodic table, we know it's going to have a 2+ charge. So that's the barium part. Let's find the carbonate part. Look up on your chart. Find carbonate. Again, it's going to be on this table somewhere. Boop, there it is. Carbonate, CO3. With a 2- charge. Okay, so let's think about what we know with regards to how to form compounds. We have charges. We're going to get ready to do our crisscross. So remember, the 2 comes down there, and the 2 comes down there. So if we were to write this, we would write Ba parentheses CO3, and then each of those would have a 2. Now, I did something new that we haven't officially been introduced to yet, and that is I added those parentheses right here. And that's because it's kind of like in math with the distributive property. When you have more than one polyatomic ion present, like we do here, we need 2 CO3s. We need to put the parentheses, because watch what would happen if I didn't put those in. If I went Ba2, CO3, 2, then it looks like I've just written Ba2, C, and then I need 32 oxygens, which is not accurate. So we don't write that down. So that's why the parentheses need to be there. Again, so we use parentheses anytime we have more than one polyatomic ion. Okay, but we're not done yet. Some of you might be thinking, hopefully some of you are thinking, but there's a 2 here and a 2 here. We learned what we do in that case. If it can be reduced, remember that we always write our formula in the lowest possible denominator. So if this 2 and this 2 can both cancel out, our final formula is going to be BaCO3. So that's barium carbonate. Let's go on to the next one. Sodium sulfite. So find sodium on your table. It's an alkali metal. Na, based on its location in the table, we know it's going to be a +1. Sulfite is a polyatomic ion. Let's look up on our polyatomic ion chart. Woo, there it is. SO3 with a 2-. So we're at the point now where we have our charges. It's time to do our crisscross. So remember, the 2 comes down. And the number that's here that we don't write, there's a 1 here that's invisible, and we bring it down. After our crisscross then, Na2, SO3. Now you'll notice in this case, what would be wrong is if I put parentheses 1, or even just parentheses. That is not correct. I'm going to erase it. That is not correct. You only do parentheses. Remember our rule over here. We use parentheses anytime we have more than one polyatomic ion. If we just need one sulfite, then we do not need to write parentheses. Na2, SO3. So what this is communicating is that we need 2 sodiums. That's what that 2 means. 2 sodiums and then 1 sulfite, SO3. Okay, we're going to try one more here. Calcium nitrate. Find calcium on your periodic table. So again, that is an alkali earth metal. Ca with a 2+ charge. Nitrate. Again, look up on the table. Look, we've even talked about it already. Nitrate, here it is. It's NO. And remember that 3 tells you 3 oxygens. That little minus is the charge of the polyatomic ion as a whole. So we have our digits here. Let's do our crisscross. Woo, woo. The 2 comes across this way. The 1 comes across that way. And we're left with, I'm going to write it over here because I'm running out of room. But I'm sure you're not running out of room. CaNO3. And now remember, this 2 comes down. So remember that we don't just write NO3 because then it looks like we're saying we need 32 oxygens, and that's not right. We put parentheses around our nitrates. This is that rule in action again. We use parentheses anytime we have more than one polyatomic ion. And this is a case that we do. We have 2 nitrates, so that's why we need those parentheses there. All right, so that is polyatomic ions, and we will continue working on this in class tomorrow.